Hello everyone, my name is Andreas. Welcome to disamtex training course and promotional video. I'd like to introduce you to the group of products in the emulsifiers category from Disamtex Chemicals, which is a paint additive manufacturer situated in South America. Disamtex Chemicals is a family-run business established around 30 years ago, specializing in chemical additive solutions for three key industries, mainly the paint sector, followed by paper and pulp, and to a smaller degree, the textile industry. And within the paint additives universe, Disamtex has a wide range of product families, and you can check our portfolio in the description box below. First of all questions is, what do we use emulsifiers for? The emulsifier will help mixing water and oil and create stability. That's the main reason. In paint industry, an emulsifier is mostly added for two reasons: reducing costs by adding water and solvent-borne enamels, and reducing VOC, the volatile organic compound, which is harmful to the environment. So by water addition, two advantages are achieved: reducing costs and reducing VOC, the volatile content. Well, emulsions are part of our daily lives. We use and experience them in many food and cosmetic products, sometimes unknowingly. If the mixture were a combination of a liquid and a solid, that would be called a dispersion. But when a mixture involves two immiscible liquids, we refer to it as an emulsion. So in paint, this would typically be water and oil, two liquids that don't match. And depending on which is the continuous phase and which is the dispersed agent, the emulsion can be either water and oil, the more common type, or oil in water. Currently, Disamtex's best-seller emulsifier is called Disastab GATPL, and this product connects to the oily continuous phase and is therefore suitable for water and oil emulsions, where oil is the main phase, so to speak. So this is the picture showing how solvent and resin content can be reduced by water addition, and leaving costly ingredients out of the formulation and replacing them with water is very desirable to all paint manufacturers without changing the enamel's effectiveness and good properties in the end. So an emulsifier will be added to stabilize this system and make that desire come true. This chart presents the Disastab water and oil emulsifier line from Disamtex, showing a comparative performance analysis of 7 different products throughout history: AT, AG, GAT, GATD, GATSM, PL, and N. Each product is evaluated according to 4 key factors: whiteness, which you see in orange, meaning the non-yellowing effect, cost saving in yellow, dryness in green, and versatility in brown. I'll speak more about versatility soon. So the graph suggests they all perform well, however with distinction to JTPL and JTN, which both demonstrate high versatility and overall balance, and both appearing to perform best across all these 4 criteria. In summary, the Disastab water and oil line provides a comprehensive range of emulsifiers tailored for different formulation priorities, from optical brightness and drying behavior to versatility and cost optimization. And as I told before, Disamtex's star is Disastab JTPL, which has found good acceptance in several countries already. And here is a comparison with other technologies and different commercial and technical aspects. Which chemistry nature does Disastab have? You may be wondering. So Disastab range of emulsifiers is based on a polysaccharide plus a nitrogen chelate, offering a balanced performance profile for alkyd emulsions. And compared to competitors, Disastab provides excellent emulsion stability and flexibility while maintaining a low cost. So it shows fewer formulation restrictions since it avoids issues such as resin saponification, brightness loss, or plasticizing effects that occur with amines or surfactant-based systems. And its recommended dosage, is usually lower than competitors, and anti-foam addition is only required when necessary, which simplifies a lot the formulation. So in summary, the Disastab line delivers stable, flexible, cost-effective emulsification for long oil alkyds, medium oil alkyds, and short oil alkyds as well, making it a versatile choice for alkyd systems. Well, what are the advantages of Disastab GTPL in more details? Here I give you several advantages and you can choose which fits best in your reality. So first advantage is the high water compatibility. Generally, the quantity of water is between 30 to 40%, but we've seen an open road to achieve emulsion states with up to 70% of water. And first point is that it allows high water content while maintaining a stable emulsion. And this increases formulation flexibility and cost efficiency. Secondly, its long-term stability. GTPL ensures the emulsion remains homogeneous over time without separation, which is a crucial property for shelf life and performance. A third advantage is its universal alkyd compatibility. That's what I meant by versatility in the previous slide. So that means it's suitable for any kind of alkyd. The product is versatile, compatible with various alkyd resins, simplifying inventory and formulation development. And another advantage is its REACH approved. So for those related to the European market, the emulsifier complies with European Union chemical safety regulations, meaning it's safe for industrial use and more globally marketable. Number 5 is process flexibility. So the customer can choose going the way either of a pre-emulsion or a direct emulsion. And I will explain more later, but that means the emulsifier is adaptable to different manufacturing processes, allowing producers to choose the most convenient way, the most efficient route. And well, number 6 is no negative impact on final paint properties. So it doesn't affect final paint parameters like dryness or gloss. Rather, it maintains the desired appearance and performance characteristics of the final product. And finally, it's globally approved. It's validated by leading global paint companies to whom Disamtex already sells. We are present in some of the main well-known paint factories you could think of. So GTPL is trusted by top-tier brands which support the performance, credibility, and quality of this product. There are some precautions to take into account when emulsifying. Okay, so before adding water, check if the rotation of the blade is creating a laminar flow, not a turbulent one, but a laminar flow in such a way that you see a vortex. Then the addition of water should be slowly but constant, because you need all water particles well dispersed and the same size, homogeneous in other words, and particles as small as possible. If water particles remain either Too big or too irregular, emulsion will break in a short period of time, for sure, because the tendency of those particles is to re-agglomerate when sizes are not equivalent to one another. An emulsion can be performed in 3 different machines: a Cowles disperser, a tank with blades, and the most efficient, a rotor-stator pump. Here is a model formulation that Disamtex suggests and sends to anyone interested. We can share this without any issues to help those who are just starting to work with emulsification. In this case, I'm showing you the single step option known as a direct emulsification, when the manufacturer wants to emulsify batch by batch. So the formulation on the screen was developed and tested in our laboratory, and we found out it works. And now here is another option, a more recommendable 2-step emulsification, which is divided into the pre-emulsion and the assembling stage. So this other option would be to add an intermediate state into the process, a pre-emulsion as we call it, which is in reality a water concentrate. And through pre-emulsions, the manufacturer can standardize emulsion parameter results and have a common intermediate stage for several different paint letdowns and colors. So first, there is a more general part formulated, followed by the more specific part, which is shown on the next slide. So the first time you see is the pre-emulsion of the previous slide. All of these percentages may vary depending on the desired solids content or the amount of water to be added. The type of resin will probably change as well. And for that, we also provide technical support. We make the necessary adjustments according to the customer's needs with no additional costs. For us, it's a pleasure to help. And to determine whether the emulsification was successful, it needs to be tested, either in a centrifuge or in an oven. I'm going to show a video of how the testing works. Well, very good. So this visually shows the test results in a stove after an emulsion made using a rotor stator pump. It was kept at 60 degrees for 3 hours, and xylene was added to induce instability. An important aspect is to fill the sample up to the lid to avoid condensation on the lid and water accumulation from precipitation on top. So in the 3 images below, we used one of our products called Amino APR to adjust the pH, and the number of passes indicates how many times the emulsion was processed in the pump. The aim is to show how stability improves when using good equipment criteria in just 15 minutes, and also by using a pH buffer when the resin is too acid, achieving better results in fewer cycles. So these slides summarize the most frequent technical issues that can occur in emulsions, along with their main causes and corrective actions. Overall, they show that emulsion stability and coating performance depend strongly on maintaining the correct chemical balance, process control, and raw material compatibility. So the charts highlight several recurrent problems in emulsion and paint formulations. And one instance is corrosion and skin formation, often due to the presence of water, solvent evaporation, or excessive use of dryers. And these issues can be corrected by using antioxidants, adjusting dryer levels, handling paints at proper temperatures, and so on. Another common problem is phase separation, either water separation or solvent or a solvent layer. And this problem occurs when emulsions are not properly homogenized. They lack sufficient emulsifier or have a low viscosity. Corrective actions include longer milling because emulsion is not ready, adjusting process parameters, and optimizing solvent ratios. Emulsion breakage, typically caused by high acidity, unsuitable solvents, poor pigment wetting, or incompatible additives such as silicone antifoams. And solutions will involve pH adjustment using polymeric defoamers instead of silicone-based ones, ensuring proper pigment dispersion, and so on. Loss of gloss or dryness. These are results from unbalanced dryers. So the fix involves rebalancing primary, secondary dryers to achieve optimal film formation and surface finish. And a tip in the emulsification art is that's a very important thing. A resin with higher solids and lower viscosity may allow higher dosages of water. So in the end, the total cost-saving amount was 17% in this simulation, a case study. Dryers, just to give a brief explanation, are metallic compounds that help the paint film dry and harden through oxidation. As I said before, there are 2 main categories of dryers, also called secatives, used in oxidative drying coating systems, such as alkyd paints. Primary and secondary dryers. And the primary dryers are catalysts. They start and speed up oxidation. Think of them as the spark plugs of the drying process. They control how quickly the surface of the film dries. And the secondary dryers, on the other hand, are helpers. They ensure balanced, complete drying, surface plus depth. And they affect the internal drying or through curing of the film. So a well-formulated paint needs the right balance of both. too much or too little of either can lead to defects like poor hardness, wrinkling, delayed drying. And this is a form sheet we send to interested parties, customers, distributors, partners in general, for them to fill in with their preferences regarding the final product they are producing, the type of resin they use, some technical information. So they send it back to us completed, and we then return it with a suggested formulation. Well, I believe that's all from me, and I thank you for your precious attention and patience to hear all this. I make myself available, and we hope our conversations can go further ahead. Thank you.